has said. We have the duty of formulating, of summarizing, and of communicating our conclusions in intelligible form in recognition of the right of other free minds to utilize them in making their own decisions. Good afternoon, ladies and gentlemen. Welcome to the valedictory session of the Engineers Conclave 2024. We are here to recapitulate the salient points from our talks during the 2 days of this conclave, identify areas to focus on, and chart the way forward in the two fields of additive manufacturing and defense manufacturing technologies. Before we begin, I would like to invite certain eminent personalities to the dais. First and foremost, I request the chairman of the session, Dr. G. Satish Reddy, former scientific advisor, Raksha Mantri, and former secretary, Department of Defense R&D, and chairman DRDL, to kindly take a seat on the dais. And I request Sri G.S. Srinivasamurthy, distinguished scientist and director DRDL, to kindly accompany him. Thank you. I now request the coordinators of the two themes of this conclave, Dr. G. Madhusudan Reddy, former director DRDL Hyderabad, and Sri Jitendra J. Yadav, Director General, Aeronautical Development Agency, Bengaluru, to occupy their chairs on the dais. Thank you. I now invite President INAE, Professor Indranil Manna, to kindly take a seat on the dais, and I request Lieutenant Colonel Shobhit Rai, Officiating Executive Director, INAE, to accompany him. Thank you. We cannot buy happiness, but we can buy plants. And that is pretty much the same thing. Let us now welcome the dignitaries on the dais with little pots of happiness. First and foremost, a striking plant to the session chairman, Dr. G. Satish Reddy. Thank you. A breathtaking sapling to Sri G.S. Srinivasamurthy, Director DRDL. Thank you. A sensational plant to Professor Indranil Manna, President INAE. Thank you. A glorious sapling to Dr. G. Madhusudan Reddy, former Director, DRDL Hyderabad. Thank you. An arresting plant to Sri Jitendra J. Yadav, Director General, Aeronautical Development Agency, Bengaluru. Thank you. Last but not the least, to Lieutenant Colonel Shobhit Rai, Officiating Executive Director, INAE. Thank you. To set the stage for the discussions today, I request the dynamic President of INAE, Professor Indranil Manna, to deliver his introductory remarks.
Dr. Satish Reddy, the dignitaries on the dais, the former presidents of INAE, fellows of INAE, very distinguished members of the DRDL family, friends. Just only yesterday we started a journey, and how time flew, hardly we could realize. But in this 1.5 days of deliberations, the biggest feeling or takeaway that I'm carrying now is a huge sense of satisfaction purely because of the quality, depth, and magnitude of deliberations. I was closeted in this very hall, and my apology to the members in the other venue, but I was so keen to follow the deliberations because the subject domain here is very close to my own specialization. And I would again repeat that the level of presentation, their quality, and the kind of experiences that the speakers brought in were absolutely fabulous. Friends, you are all aware that Indian National Academy of Engineering is the only peer body in the country in the engineering and technology domain. And just for those who have probably not heard us before, INE comprises experts chosen from three main quarters: the industry, the academia, and R&D organizations, including the strategic departments. We ideally should be having 1/3, 1/3, 1/3 from these three quarters, but the distribution is not exactly the ideal. And for the last few years, INE has been making conscious efforts to restore parity. INE also is very keen and having affirmative action in terms of having more number of women in our fellowship. That's also happening. Still, no harm in acknowledging that the representation is not even in 2-digit, less than 10%, but should happen sooner than later. We are divided into, not divided, we have kind of distributed ourselves into 10 engineering sections, and these 10 engineering sections take care of the entire gamut of engineering and technology, particularly in the context of the country's developmental agenda. So we are an academy of engineering. We are not an academy or club of engineers. So we are devoted to the cause of engineering and technology. And some of you would have heard me saying, and that's exactly what we believe in the academy, that the country, in order to reach the lofty target, and a very justifiable target in the words of the Honorable Prime Minister, Viksit Bharat or developed nation, has to deal with a number of issues which are all essentially of engineering nature. Now, by development, you cannot measure only by the economic numbers of GDP and growth rate and so on. But if you really have to solve issues faced by the common masses in terms of habitat, transportation, climate, sustainability, security, and so on, all these issues are primarily of engineering origin. And that's why exactly this academy has a very major role to play. But then the governing council of the academy realized that we are hardly less than 1,000 as the real foot soldiers of the academy, meaning the fellows. And it is so because right from the inception, academy has been very quality conscious. And we end up selecting every year hardly 10% of the nominations we receive. So because of which the governing council realized that we are not able to do justice to the huge developmental agenda, particularly in engineering technology. And we need more of the professionals, very successful engineering professionals, to be brought into our fold. Now, the criteria by which we elect a fellow is very stringent and also is designed with a very different philosophy. For example, nobody is elected a fellow just because he or she happens to be director of a laboratory. We go by individual contribution. Now, in a platform like DRDO, where you develop the most important defense materials and components for the country, nobody can claim that a missile is developed by Dr. So-and-so. You have a team and you have generations of members who contribute to bring it from level 1 to 2 to 3, and it's a continuous journey. So in the process, when we elect somebody by virtue of an individual contribution, then obviously we miss out very many without whom this successful campaign on missile development or any other such implement is not going to be possible. So then we are not doing justice to a very large number of professionals in the country who actually deserve to be part of INE because INE wants to serve the nation. So, taking this into account, the Governing Council decided very recently, and last year and this year it got approved, that we'll embrace a much larger number of individuals as members of the Academy. And these members will have a different criteria of selection. And instead of 1,000, we would like to go an order of magnitude higher, up to 10,000 members as a part of INE. So obviously all these details will come to you through your laboratory leadership and other organizations. So we are looking at professionals who have not only an engineering degree or associated in engineering program, but are also in the profession for a certain number of years. So all those details will reach you, and also in terms of the benefits, whatever you can expect. But the reason why I thought it was prudent for me to mention is the following. That going by the quality of presentation and the kind of work many of you have done and presented, we are convinced that by creating this membership cadre of INE, we actually can serve much better and more effectively towards the developmental agenda of the nation. I'd be failing in my duty if I do not once again reiterate that INE is immensely grateful to the leadership of DRDL, starting from the Secretary of the Chairman DRDL to our local organizing committee, each and every member, Dr. Jaideep Joshi being the leader of the pack, and all DRDL director, all other lab directors in Hyderabad and elsewhere, for making this a very memorable congregation. Engineers Conclave is one of the very important calendar events of INE. We start with our National Frontiers of Engineering, aimed at very younger population of the engineering fraternity. Then we have Youth Conclave, and then Engineers Conclave. Engineers Conclave, as you would have seen, always traditionally chooses two topics. And going by the words of Dr. Kamat, this year it's just a coincidence. One topic comes from INE, another from the host. This year it so happens that one of the topics happens to be a subset of the other topic. I mean, in the process, we actually would have done a much more thorough and extensive job. And that's what I think all of us are very keen to now hear from the chair of the panels, which discussed and who are going to give us specific recommendations. Now, Engineers Conclave, one of the major intention is to collect actionable recommendations. We normally would forward these to the concerned ministry and discuss them through our consultative committees as to how we can take forward. In fact, Dr. Satish Reddy would recall that we have had similar consultative meetings between DRDL and INE. But now we want to go one step forward. And what we mean is that from INE, without waiting for anybody, we would also like to see what part of it can be implemented directly through INE's own intervention. And this much we owe to the nation. If we consider ourselves to be the peer group in the country, we have to deliver something which will make the common citizens of the country realize and acknowledge that Indian National Academy of Engineering is a very active and effective organ in the country to pursue the agenda in engineering and technology. So I'll again thank the organizers for this very successful campaign. Each and every presenters who presented, even every member of the audience who took part in various deliberations in this hall and the other hall, and we have had very enjoyable experience to take back home. And we look forward to having more effective, fruitful interaction with DRDL fraternity. Thank you very much, and Jai Hind.
Thank you, sir. The monumental task of organizing the two technical sessions, listening to each talk, and consolidating the significant points has been carried out by the two coordinators. I request the coordinators to sum up the technical sessions for the benefit of all the delegates. First, I invite Dr. G. Madhusudan Reddy, former Director DMRL Hyderabad, an outstanding scientist, to sum up the Theme 1 session, on additive manufacturing for defense applications.
So good afternoon, everyone. Respected Chief Guest of the function today, Dr. G. Satish Reddy, Former Scientific Advisor to Raksha Mantri and Former Secretary, DDR India and Chairman DRDL, Professor Indranil Manna, President IME, J.J. Yadav, D.J. Adar, and Director DRDL, Colonel Shobhit Raj, distinguished speakers, IME fellows, honored guests, ladies and gentlemen. It brings me great satisfaction to summarize the technical sessions and additive manufacturing for defense applications. During the inauguration, our chief guest highlighted the two themes chosen for this year's conclave: additive manufacturing and defense manufacturing are crucial for enhancing our nation's competitiveness and driving economic growth. Our guest of honor, Dr. Samir Vikaman, highlighted the significance of accelerated materials development and additive manufacturing in material science, setting their relevance for current advancements and future needs in this field. Yesterday and today, we had 4 sessions, that is allied development, powder processing, design of additive manufacturing machines, and design for additive manufacturing, qualification, certification, and applications. Featuring a total of 16 talks, along with one plenary talk and a panel discussion on additive manufacturing. The plenary and keynote presentations highlighted the latest advancements in additive manufacturing, focusing on materials technologies. They covered a broad range of topics, including structural, functional, and healthcare materials, dwelling into physical and mechanical metallurgy, processing, characterization, and performance evaluation. The first session was chaired by Professor Dhanush Rao on allied development. But you know, metal additive manufacturing can redefine engineering design for complex parts. Understanding process parameters, microstructure, and mechanical properties is essential, as small changes can greatly affect performance. Optimizing machine settings and pin parameters is crucial for achieving desired outcomes. Professor Satyan Subhas from Institute of Science discussed the current status and future needs of additively manufactured metallic materials. He emphasized the importance of understanding microtexture, bulk crystallography, and their impact on mechanical performance. He also brought out the emerging facets of science behind additive manufacturing. Professor Janaki Ram from IIT Hyderabad discussed trends in allied development, stressing the need for a broader selection of bill materials. He outlined strategies for creating high-performance printable alloys and highlighted the benefits of microalloying. He also emphasized the importance of rationalizing alloys for additive manufacturing and its sustainability implications. Integrated computational materials engineering approach promises to shorten the time required for accelerated development of additive manufacturing alloy components. This involves multi-scale modeling and transfer of critical information across different length scales. Professor Panikumar from IIT Chennai highlighted the state-of-the-art advancements in accelerated materials design and development, presenting case studies on nickel-based superalloys and aluminum alloys that are particularly relevant to the strategic sector. The second section on processing of powders, this was chaired by Dr. Balamurali Krishnan, Director DMR. You know, well, powders are vital for additive manufacturing. But currently, most of the feedstock powders imported and available for select grade of materials. So building powder manufacturing capabilities in India is essential. Dr. Vijay, Director ARCA, has covered efforts at ARCA in developing metallic powders for additive manufacturing through inert gas atomization. He noted that gas atomization is effective, but this method has limitations, including high energy consumption and defects like surface oxides, porosity, and strut-like particles that can impact the quality of additive manufacturing parts. The plasma rotating electrode process is promising for producing high-quality powders from various materials such as titanium alloys, refractory materials, aluminum alloys, and nickel-based superalloys. Professor Krall from University of Hyderabad emphasized the engineering aspects of prep equipment and the benefits of prep powders for additive manufacturing products. Designing alloys for additive manufacturing enhances powder flowability and packing density, resulting in fewer defects and high-quality parts. Sri Sachin from Indo-MIM discussed how computation tools like Calipad, that is calculation of phase diagrams, and machine learning can expedite alloy development. The third session, the director from CMTI, Naga Anmanaya, chaired the session on design of additive manufacturing machines. India has experienced significant growth in adoption of metal additive manufacturing in recent years, particularly in industries such as aerospace, defense, medical, and automotive. However, the country's utilization of this advanced technology remains lower than the global average due to various factors. There is a pressing need to indigenize this technology and raise awareness to promote widespread adoption, thereby future-proofing it against technological disruptions. Professor Karanathan from IIT Bombay discussed the challenges and associated with indigenously built electron beam hybrid manufacturing and highlighting the advances of both powder and white stock. Dr. Viswas, Director of CEO, MS Solutions, elaborated on key challenges that have been overcome in the process, as well as current obstacles hindering the growth and the adoption of this technology in the country. Professor Murugan from IIT Chennai covered the basic principles and effectiveness of in situ monitoring systems through real-time laser beam shaping and defect monitoring in the laser powder bed fusion additive manufacturing process, emphasizing their importance for immediate industrial applications. And the fourth session, that is on design for additive manufacturing, qualification, certification, and application. This session was chaired by C.A.V.V.S. Prasad, CE Semilab. The space industry sees significant benefits in additive manufacturing, especially in reducing lead times. However, qualification and certification are crucial for its adoption. As strict regulations and lack of established AIM standards pose challenges. Developing internal standards and building confidence in AIM technologies are essential for ensuring safety and reliability in this conservative sector. Dr. Suryanarayan Murthy from LPSC ISRO emphasized that many unknowns still exist in additive manufacturing process. He highlighted the importance of component testing under simulated conditions for product qualification to assess the effects of defects. Balancing qualification requirements involves understanding performance expectations alongside the capabilities of the process. Dr. Murthy presented various challenges faced by the space industry in the qualification and certification of AIM products, supported by real-world problems, examples. Dr. M. Shamsundar, Vice President of Indian Society for NDT, outlined how predictive analysis powered by artificial intelligence and machine learning are being developed to anticipate potential defects based on data collected during the AIM process. This proactive approach is expected to drastically reduce the time and cost associated with the post-manufacturing inspections and rework. He also addressed issues related to in situ monitoring challenges and the importance of workforce development and training for reliable AIM components. Dr. John, head the Center for Additive Manufacturing DRDL, discussed several challenges faced by the Indian AM ecosystems, including the availability of indigenous material powders, lack of local machine manufacturers, and the absence of indigenous software for design, pre-processing, simulation, and process optimization. He effectively covered opportunities for additive manufacturing in defense applications. Professor Sarvana Kumar from IIT Madras explained that while AM offers great design freedom, it also presents constraints. Designers must consider factors such as layer thickness, support structures, and material properties when creating designs. Different AM technologies and materials yield varying thermal and mechanical properties, which can affect the final product performance. Understanding these constraints is crucial for developing more efficient and effective designs. The Vice Chancellor of Godavari Global University, Andhra Pradesh, Dr. U. Chandrasekhar, discussed the significance of laser powder bed fusion in metallic additive manufacturing for its versatility and ability to create complex geometries. He noted that LPBF components outcomes are affected by process parameters, leading to issues like high residual stresses, porosity, and poor surface finish. He highlighted how material properties such as heat capacity and melt temperatures can mitigate these problems. However, changes persist in applying test data from coupons to thicker parts, emphasizing the complex interaction between materials and process in optimizing engineering systems. All the talks were intellectually inspiring, thought-provoking, and comprehensive in scope and content. During the past 2 days of deliberations, we recognized that there are numerous challenges and opportunities in this field. And this conclave has given a valuable insights into the dynamic world of additive manufacturing. I shall briefly highlight certain major recommendations for consideration. Thousands of alloy systems are presently in use as engineering materials for various applications. However, powders for additive manufacturing are available only for selected grades. To promote the wide application of additive manufacturing for beneficial results, there is an immediate need for development of processing technologies for preparation of optimal powders in more of these alloys. There is a need for exploitation of computational methods such as integrated computational matrix engineering, artificial engineering, artificial intelligence, machine learning for accelerated development of advanced alloy systems for additive manufacturing, together with appropriate powders. Indigenous development of custom-built AM machines needs immediate trust for catering to the specific requirements of Indian industry, in particular strategic sector. The evaluation of real-time NDE and in-process monitoring for detection of defects generated during additive manufacturing calls for urgent attention to ensure the all-important structural integrity of AM products. To realize the unique certification advantage of AM products by Indian engineering industry, the need for clarification standards are non-existent. Therefore, there is an immediate need for development of holistic certification standards for additive manufacturing products with close collaborative efforts by all stakeholders. Suggestions were made by several panelists and INA authorities about increasing the outreach of INE in additive manufacturing, involving a professional body of academia, R&D, and industry. INA responded positively and promised to work towards it. The fine print of this proposal shall be initiated while finalizing the recommendations. I am confident that this event has added momentum to our national efforts to enhance the defense manufacturing sector. This engineering conclave has laid the groundwork for the expanded application of this additive manufacturing technology. on behalf of the organizing committee, on my personal behalf, I am thankful to all the speakers and participants for their active participation during the various sessions of this Engineering Conclave 2024. I conclude by acknowledging the untiring efforts of my entire team in organizing this event in an impressive manner. I wish to thank every one of you for your efforts and time to participate in this prestigious event and make it a grand success. An event of this magnitude would not have been successful but for the generous support from all our sponsors funding through generous. Thanks a lot. Thanks once again for your efforts and your participation. Best wishes, warm regards for happier times ahead. Thank you very much.
Thank you, sir. I now request Sri Jitendra J. Jadhav, Director General, Aeronautical Development Agency, Bengaluru, to sum up the Theme 2 session on Defence Manufacturing Technologies.
Good afternoon to all. I may not able to summarize like how Mr. Madhusudan summarized. But some 1 month back we sat together along with Jayan Patil, and he has told us that frame the session in such a way that all the manufacturing in defense, whether it is ground vehicles, whether it is maritime vehicles, whether it is airborne vehicles, will get covered. So what we did as a theme 2, we taken his advice and put ground-based defense as one session. Then second one was the aerospace defense, that is airborne systems session. Third one we took a maritime defense session. And the fourth very interesting session which we done is the technologies, because defense manufacturing technology session has been given a flavor at the end. So it was a very wonderful sessions we had. In the ground-based defense, we have 4 speakers and 3 speakers, and it was chaired by Dr. Sanak Mishra. And we had a first from Tata Advanced Systems and one from the government, that is at the present Armored Vehicle Nigam Limited, and one again from the private, from their end. So the sessions were also mixed in such a way to get insight from the private as well as the government department. So that way we went forward. So in this session, all the speakers have well presented their thought process, and every speaker has been told what you expect from the INE. So that slides were also presented at the end of the session, because ours was not so complicated subject like what Dr. Madhusudan has to handle. Ours was a straightforward subject. So we could able to structure it well, and I found that in general from these 3 presentations, the thing that come as a challenge is there is a high dependency onto the, even though we took a technology transfer from DRDL or various things, there is a high percentage of import content in that, and that is driving the deliveries. So that is the first thing has come, because I am commonalizing the outcome of this presentation, and the similar things which has come from out of 3 presentations is, one is this. Second one is materials. So they have had to take indigenization materials, but more or less, rather than indigenization, many people told that they take a technology, then some material get defined of ghost standard or something, then equivalent material available, then certification agencies doesn't allow put that as the equivalent material, they will ask all sorts of testing to be done. So that sort of problems are there. Third thing which has come from the L&T, which was a fantastic presentation, where L&T has used a complete digital manufacturing technologies, right from the RFP stage to the deployment, and they made that lifetime possible in 24 months. And that was a great presentation where how the manufacturing technologies are getting matured to increase the rate of production. So that was a very good presentation from Mr. Ramchandani of L&T. And further to that, the main basic thing that's recommended by our session chair, Dr. Sanak Mishra ji, is there should be a proper policy in place to get collaborations of public-private partnership. And though policy exists, but there should be a flexibility should come to operate for the development organization with the industry. So that was a major recommendation has come from the session chair. He is sitting here also, but while doing our validity section, we can take few more recommendations. The second session was chaired by Dr. R.K. Tyagi, and there also we kept 3 presentations, one for fixed wing, one for rotary wing, and one for civil aircraft. And there also the general thing was common, I found. Whether ground systems people had a problem, airborne people also facing some problem. Their problem was also the high content of import in the TOT, leading to the supply chain resilience and then affecting the deliveries. That was a major concern. Also, there is a material indigenization, coating indigenization was also brought out there. And the main thing which are taking problem of delivery is basically the engines, seats, actuators, like that has been informed. And also helicopter people are largely dependent upon avionics also onto the import, which is the first time we have heard. So session chairman Dr. Tyagi ji has given a wonderful recommendation. So first it has been told that the commonalization of the technologies, which where helicopter people are importing everything, including radar, EW, everything, and they don't know other side the developments are quite at high TRL level in aircraft. So that needs to be harmonized. That is the first recommendation. The second recommendation, before going for recommendation, on the civil aircraft, NL has presented their views, and it was strongly recommended by Dr. Tyagi ji that there should be a start for RTA project. And also NL has brought out 2-3 important things about the certification process, because everybody more or less in this sector was telling that certification during design and development has to be a simplified process, especially non-critical systems can be given, like we are talking to President ESI along with CSML, the same thing that's come DR, CR concepts into that. And also there were a lot of concerns about the R&D investments, tax rebates on R&D investments, then tax rebates onto the R&D related other things, which will reduce the cost of the project. So these are the recommendations has come. Dr. Tyagi ji has given a very, very prospective recommendation that there should be a defense finance corporation, because he has told that about 5 lakh crore business is there in defense for next 10 to 15 years, and such a finance corporation like power sector now, how oil sector, power sectors, how the revolution has happened. There is a time has come for the defense manufacturing revolution, and that has to be supported by Defense Finance Corporation. So I think that recommendation we should take it forward. Of course, the third session was on manufacturing technologies, which was chaired by Dr. Jha. Very interesting session. Mrs. Adani had presented their views about UAVs. Then there was a very good presentation about the coatings from NL, a good presentation about the advanced alloys development happening in Medani, and also there was a presentation from Bell about the mission systems. So the overall that session was very technical, and their thing is also like R&D should be funded and supported by the government, and that sort of thing. So Jha Sahab has also given recommendations like we should fund more percentage of what you call profit to the R&D from the public sector, and commonly public sector, private sector, commonly along with government sector should take the R&D forward. So it should be a equal sharing or some percentage sharing to take R&D forward, so that everybody is responsible for that R&D. So that sort of recommendation has come. So far, so good. Thank you very much. I have covered many points in a short thing, and then we will leave the floor open for the questions and answers. Thank you very much.
Thank you, sir. I now request the co-chair of the session, Sri G.S. Srinivasmurthy, distinguished scientist and director DRDL, to kindly address the audience.
Dr. G. Satish Reddy, former Secretary DDR&D, Chairman DRDO, SA to RM, and Dr. Mansudan Reddy, former Director DMR, Jha, DG Hada, Professor Indranil, and Lieutenant Colonel Roy, Sri U. Rajababu Garu, DGMSS, Dr. Joshi, Program Director, and lab directors from other DRDO laboratories, members from industry, academia, my dear scientists, colleagues, ladies and gentlemen, very, very good afternoon to you all. And really I am happy to see such a big gathering here, lot of scientific community, industries, academicians coming here on our invitation, sharing their experiences, their technical knowledge here on the common platform. Last 2 days, really it's a festive environment here, and people participating with a lot of energy and enthusiasm. Here, everybody, we have a lot of tasks to do every day. Once we get to office, a lot of things will be there, and we'll be immersed doing those activities every day. But then we have to introspect ourselves whether we are going in the correct direction or not. Everybody feels that yes, we are doing our best, but unless we come to know about things what are happening in our own area, in the worldwide, we cannot say where we are. The technologies, in whatever the area you call it, you may identify, they are changing every moment. So unless we keep ourselves updated abreast with the rest of the world, we will be lagging behind. And of course, as a nation, in the manufacturing technology, be it additive manufacturing and different applications, we are putting a lot of efforts. And last decade, if you see, a lot of manufacturing technologies we have developed, almost we are on par with the rest of the world. And this is all because a lot of efforts made by you all from the nook and corners of the country, be it an academic institution or industry or a research laboratory. We are putting a lot of efforts. And I am sure these efforts will continue, and in a short while we will be one of the global leaders in the manufacturing technologies. And if we see in DRDL and particular DRDL and DRDO also, the techniques we are implementing, and we are going to implement new machines, new manufacturing techniques for mass production of users' requirements, day by day we are improving. And I am sure we are geared up to the requirements of the users, and thousands of weapons are the requirement. As you see in the worldwide scenario, if you see Russia, Ukraine or Israel, the kind of weapons they are using continuously, and the spending of weapons every day, hundreds and hundreds of weapons are being used. So, on this mass rapid production should be initiated, and we already initiated the steps from the DRDL side, and we are sure for whatever the missiles we have designed and developed, we are sure with the help of our industry, we will gear up the production to meet the services and countries' need. And last 2 days, a lot of technical papers were discussed. Many people have presented their work here. A lot of interactions were there. I am sure people would have gathered a lot of knowledge, and they are going with a wealth of knowledge back home. And this is happening regularly. But thing is that one thing we should remember and bear in the mind is that what is that we are learning here, we should not leave it here. We have to continue. What are the interactions we have today or yesterday? We should continue that. That tempo should be maintained. What are the initiatives we took that need to be progressed further? Otherwise, we stop it here. Once again, we go to the beginning. So the same thing I was discussing with Dr. Joshi. What are the findings are there? New findings are there? I requested him to sum up, so that as a laboratory, I will also take initiative, coordinating with all the rest of the world or India to improve ourselves to meet the user's requirements. And really, once again, before concluding, I thank all the participants taking time out of their busy schedules, coming here, making the program a grand success. I personally thank Satish Reddy Sahab taking out of his great time and coming here and this occasion. Thank you very much, sir. And I wish you all the best, and I hope we keep interacting with each other in the future also. Thank you very much.
Thank you. It is indeed fortunate that Dr. G. Satish Reddy, former scientific advisor to Rakshana Mantri and former Secretary, Department of Defence R&D and Chairman DRDL, has consented to be the chair of this session. So without further ado, I now request Dr. G. Satish Reddy to kindly deliver his address.
Good afternoon, everyone. As this is the valedictory session and the final session of the two-day event happening, just before I say something, anybody else who wants to say, because there are both the teams, summing has been done by two eminent personalities here, and having heard this, and as it is a combined session what we have now, anyone else here like to say anything? Achal ji sir.
I am told that from this in the Additive Session, I am saying in the mission it should be AI based. So, because if you use the mission system should be AI based. What I do, I am not just using buzzwords. I am doing from the old system, data lake, input and output should be taken as a knowledge base and feed the machine learning and take number of neural networks and with more deep learning get the thing. So this is the thing in the mission system should be identified. In that, the transition from the old system to new system will happen. I told Jalal many times. That is one. And the other one I'm surprised. See, I thought this I learned from our great man, you should remember his name, Dr. Conclave, DRDL director. During COVID time, I was with him. And I got COVID because of Hyderabad factory, who got the machine. There they did the gold. Everybody is saying gold is impossible. Yes, but this point I will just finish. I just finished in 1 minute. I have just 2 points. Gold powders, how it can be made. So this particular point, where sensors are required, nobody has mentioned. Sensors are required, processors are required, drive mechanisms are required to make the machines. That is missing. And actuators, I've already told, they know it.
Anybody else? Okay then, right. Thank you. Thank you, sir. Professor Enamil Manna, Dr. T.S. Murthy, Sri Jadhav, Dr. Masuran Reddy, Colonel Sharut Rai, and all the people, eminent people who are present here. A very good afternoon to all of you. Firstly, let me congratulate Professor Manna for having this engineers conclave here, and also like to congratulate and appreciate DRDO, the Secretary R&D, and then the DG MSS and Director DRDL for holding the conclave here in DRDO and at DRDL Hyderabad. Also, the teams having conclave happening here in DRDO. So both the teams are connected to the defense, whether it is additive manufacturing or the manufacturing technologies for defense. Both are connected to it. And I definitely want to appreciate Professor Manna very specifically for holding or having this engineers conclave now, and particularly as Chief of INAE, taking INAE forward through the most difficult times. I think I say that last about probably 2 years, INA has been going through the most difficult times. He has been dedicated to putting all his efforts to see that the INA comes out of that phase and continue to be an eminent engineers body in the country and have its stature globally. And so in this time, it's holding this conference and DRDO coming forward. That's why I very specifically want to appreciate both Professor Manna and DRDO. Also, I'm also happy to be in the Engineers Conclave, as when the first Engineers Conclave happened in New Delhi in 2013, I think, and that happened at Vignan Bhavan when President of India, Pranab Mukherjee, came. So I was very actively involved in that conclave. That was the first ever conclave which happened on engineering interventions in Sundarbans and then the manufacturing technologies. Again, the theme was that, and which happened in a very grand scale in Vignan Bhavan when Mr. Avinash Chandra was the chairman of the DRDO, took up the responsibility of doing it along with many others, Professor Goyal and Professor Suresh, who are here, who were very active at that time in that conference also. Also happy that having in this valedictory session in this hall, I think this hall was inaugurated by none other than Vice President of India actually some time back. And happy to see a lot of people in the valedictory session also. Normally I thought we are going for a valedictory session, maybe there is a 50% attendance and half the people will be sleeping and all that, but still people are active and a lot of people are there. It shows that the importance and how we are actually participating. Coming to the two themes, the additive manufacturing and then the defense manufacturing. The first one, Dr. Masood Reddy gave a detailed brief of the whole discussion, what has happened, how many sessions have happened, who all talked about what, who shared and who, what it is and all that. So looking at that, I think country is evolving itself good in the additive manufacturing at various centers. The activities related to additive manufacturing are taking place people have understood the importance of additive manufacturing and the ease with which critical components, critical systems, or even assemblies, or where assemblies with multiple things can happen, sort of a thing, can be carried out using additive manufacturing, I think, taking up shape well. And a lot of engineering developments are happening in the country in that front. But having understood that, I like to say that where do we want to head? What is the goal of the nation in this? Firstly, there are three components in this. One is, as an additive manufacturing, we become experts in that. We try to produce various components. We try to produce various critical parts out of it and produce it is one aspect. Second thing is the raw material, the powders which are required for it, and that's second part. Third is the machines and equipment. These are the three things. So when you look at it, I don't have any doubts that we will be able to, in this country, probably as the time progresses, there are a lot of machine shops in the country which come here and we will be able to produce many parts. I like the way we are now, the supply chain, global supply chain, we will be part of that. And there are many industries which have started also in additive manufacturing also trying to produce and trying to be part of the supply chain, global supply chain we are trying to do it. So which I call it as a service industry. Yes, you are having background of it, you are able to do and you are able to produce and you are able to do it. So one aspect which we are doing it today with the conventional machines also. This is number one. But then, do we just be happy with that the way we are doing now, or like to have the complete equipment, the machinery, what is required for various technologies based equipment which are required for additive manufacturing? Do we become a manufacturing country, house, and try to supply those machines globally? This is what is one important question like to have. Today, you see thousands and thousands of machine shops what we have in the country, and most of the equipment, whatever CNC machine, 3 axis, 5 axis, 7 axis, 9 axis, whatever we say, 90% of them are imported. Yes, sometime we tried in the country, we had HMT and we were trying to produce, and then again it has fallen down, whatever reasons and all that. We should not land up in the same situation as far as the additive manufacturing equipment machinery is also concerned in the country. There are a couple of industries which have come, one or two in Bangalore itself, who are trying to produce, who are actually producing the machines and trying to supply. I think I heard somebody met me recently, a startup also, who have come out of it and then who are also producing. But that number should go up and the machines, equipment should be state of the art, and that we should be able to compete globally, technologically, and then of course the commercially wise also we should be able to produce. This is one important thing. What should we do for it? This is number one. Second, the raw materials. Various powders that are required. Where can we become self-reliant? Is a question. I think Dr. Masood Reddy was also mentioning about it, was discussed in a thing, what needs to be done. Whether raw material, actual raw material is as a natural resource available in the country, or do we need to take it outside? What is available in the country? How do we extract, how do you process, how do you produce those powders? Or how do we, if it is outside, how do we get seamlessly, does it become critical supply chain for this country? This is another important aspect what we need to look at. So what I mean to say, the three parts are equally important. We are not trying to neglect the service sector, the equipment, design, manufacturing capability to design those equipment which are state-of-the-art equipment and which is an equipment which is better than, which is available outside, or we are technologically having an edge on that. and second thing is producing the raw material within the country or trying to have those material available in the country at a lower cost. So we need to look at it. How do we see that? I also see that additive manufacturing is everyone tries to work, and whether it's defense or other side or wherever it is, and a lot of requirements are there and people are working on that and everybody is working. What are the requirements they have? Do we need to have a central body or something, and who can coordinate all these activities? Try to see what is happening, what are the gaps, what needs to be done, how to see that a funding mechanism can happen, or how to influence the government and see that sort of an important thing. Or do we need to have couple of places, center of excellences in each of these areas connected to additive manufacturing is one important thing what we need to see. So these are at a strategic level, a strategist level, and at policies level what needs to be looked at, and try to see that how, today example, you take the country thought quantum technologies, the country should be taken very forward. There is a quantum mission which is trying to take, and a lot of fund created, and say somebody and some body is created, and somebody is leading, there is a CEO or chairman, somebody is created and trying to fund various organizations, various academic institutes, various R&D organizations, various startups and all that. May not be that much a research and all that, which is a very frontier technology or going to be future technology. But here, this is already a technology which has started flowing in. What needs to be done and how a mechanism needs to be arrived here is one thing. What needs to be looked at it, I think, when we think, and when as an IAME also when we submit it to the government, this important aspect need to be brought in is what I feel. Probably I am not very sure. These aspects should have been discussed in detail also, as I have not participated in the discussions, I am not very sure. But this is what has come to my mind and what to say. Coming to defense manufacturing, the second thing. Today we should look at in a manufacturing side, not on the technology side probably, I am talking about as a manufacturing. What are the gaps we have in the country? Why we are not able to manufacture certain things in the country, and how do we do that is one thing what we need to look at. Like example, there are many facilities or infrastructure which will need to be created in the country, which probably if we take out, maybe there are about 10, 15 important facilities, infrastructure, what needs to be created in the country to have those things. Let's say, example, we talk about aero engines. Everyone talks about aero engines. That is one thing which we are not produced in the country, what is required. So what are the things which are required? In the, whether the material technology, manufacturing technology, test facilities, whatever it is, where we talk about very high-end, high-capacity press, what we need to have in the country, whether to produce that type of engines, bigger engines, even though DMR has produced the single crystal blades which are required for the engines of the helicopters for the HAL, and what is required for aircraft or the technologies what are required, are the high altitude engine test facility what is required, or the wind tunnel whatever is required for testing of those things, is one of the important things what is required. I just gave an example of aero engines. This is one important thing what we need to have in the country. Without the necessary infrastructure, necessary facilities, it is impossible for any country to develop on its own, because nobody will allow you so easily to come in, and probably you have to struggle in such a way that you are already delayed in that, and then you come out with those particular systems after somebody has produced and they have gone ahead so much, and then we are lagging behind in the technology, suddenly it happens. Similarly, look at today, we need to invest a lot in focal plane arrays, FPS, a device you take it, is an important thing, what is required, and thousands and thousands and thousands are required here in the country, and we are dependent on this to get from outside, and we are trying to continue with that, and other parts also require JT cooler or Stirling cooler or whatever it is required is an important thing where we need to invest. Probably it is not that we do not have technology to have them, that I think definitely we should be able to ensure, but what is required is investment in it and decision to do it and try to have a facility in the country to produce them, which are required in tens of thousands, and probably if we export it will be much more than that. And today we are talking about the next technology, uncooled fellows, the bolometers which are required, again the same thing happens. Talk about any device and any sensor, I think we just, Dr. Chaudhary mentioned about it. You talk about any device, any sensor, leaving aside the semiconductors, we need to have the facilities, infrastructure to develop them and produce them in mass, what are required at a lower price compared to others is what is important. Today you talk about higher wattage laser diodes, you talk about acoustic sensors, you talk about other sensors what are required, MEMS, NEMS, so many other devices, impact diodes or whatever it is, all these things are very important. I am calling it as manufacturing one. I don't think there is too much of a technology gap in the country not to able to produce that, but primarily out of the capability to manufacture in the country, I think we are lagging behind it, is what I strongly believe in these areas. This is one important thing. So we need to identify what are those things. I just give a couple of examples. Probably we can go through it and see that these are the important essential infrastructures, facilities and manufacturing centers which are required in the country. Try to manufacture these important critical parts and critical systems or systems whatever required, and all that is one important thing what we need to look at it. Second, what I feel is, even though we have been doing extremely well, and definitely I feel very strongly today in the global scenario, India is one which is coming out with the systems from drawing table to a prototype very fast. I think definitely I consider India is one of the top countries in the world today who is able to come out. The example being the lightweight tank, which has rolled out in just less than 2 years. It is a very important development. Likewise, we have seen a couple of missiles which have come here very short time period and which have come out and which are getting testing and all that is important. But then, still as a country, as we have been lagging behind and the world has moved ahead, there is a need for us to develop these things faster. I am not talking about decision makings and other things, issues at Delhi or various other things. Still, I feel a lot more mechanisms, a lot more technologies which are required. Maybe we need to look at, think how these things can be done, how the prototyping and taking it to the trial stage, we can do it much more quicker. There are a couple of examples. How do we replicate these examples what we have done into the overall system and try to see that most of the things, it is not possible to make every system to come out fast, that there is nothing R&D or development in that at all. If it is, if everything will come in 2 years, it is just that we are doing engineering, we are not doing any R&D. And somebody asks, I want every system to be successful, then that means he is not asking a scientist at all. No scientist can give, there is no research which is without a failure. Then there is no research in that at all. That is a separate question, I am not saying. But whatever we are confident, and most are trying to do whatever we are talking about D&D, those D&D, how do we do it quick and faster is another important. Third, looking at today, the global scenario, last year I worked on a detailed paper and submitted to the government. What are the opportunities for India globally in defense? Both system-wise, subsystem-wise. Huge. Huge opportunities are there. Talking about opportunities only for India, I am not talking about the whole thing. What I mean to say, map what all the things which world globally each country looks at. In that, what are all the systems India has the capability to develop them or produce them, and looking at, and when I took in that opportunity, just 10% of it when I looked at it, huge requirement. It is going to, one going to be on 50 billion, another going to be on 30 billion, is what is the requirement per year, what has come. The paper, the details are there, which I can share it also. So such is the huge requirement. So how do we see that our manufacturing technologies here in the country, leaving aside the very important aspect of marketing capabilities, there is another important, very important aspect, marketing strategies, marketing capabilities. How the manufacturing technologies can make you capture this market is one thing what we need to look at. What I am trying to say is, manufacturing technologies, meaning capability to produce them, capability to produce at a lower cost. So that is why that word has come, innovative manufacturing technologies and capabilities. I think sometime back, Joshi and me and some of others here have worked on that. United States of America, that time itself, I'm talking about 4 years back, has come out saying that there should be 32 innovative manufacturing centers of excellence in the country in 32 areas to see that you are coming out with technologies which can make it quicker, green, cost-effective, efficient, and lower price. That is the aim of this. So, how do we have in all the manufacturing sectors? Many of the sectors are common, whether you say defense or space or whatever it is and all that. How do we have such innovative manufacturing capability in the country here, which ensures a quick, a faster, lower price, green production capability in the country, so that we are globally competitive to capture this market is the thing. When we say that India should make for the world, when we say make for the world, how do you make for the world? Make for the world is one is technology, you are competitive in the technology or you are also equally latest. Second thing is you have to be both in quality and price, you have to be competitive. So that comes out of the technology, one important thing what we need to look at it. So we need to look at those technologies and can we have such innovative manufacturing centers in the country in the various sectors of the defense what are required is another important thing what I feel that we need to look at. So these are the 2-3 important aspects in the defense manufacturing what are required. And lastly, I think as I just came in here, Dr. P.S. Goyal was just mentioning me. So today everyone globally or in India, whoever it is also, talks about a war of 10I, 15I and all that. But looking at globally, no war is ending in 10 days or 15 days at all. It is running, sometimes it is running months and sometimes it is running for years also, and then multiple things are happening and what is that? So, suddenly you need that, no, these are what, the depleted all the things what I have, I want very quickly these things to be produced. How do you produce? What are the mechanisms? What are the processes? Not just technologically also, even as a strategy wise. Do we have a strategy to gear up for that? And that is another important thing also what we need to look at it. How do we gear up for that and try to make this? See, this also happens, one thing is, the production line, how do we maintain a production line is one of the important things what is required. I remember when BDL was producing Akash, I think they came up with the capability of 60 missiles a month. It's not small. In India, one organization coming up saying that I will come up with 60 missiles a month. And I remember somebody asked, these numbers are not sufficient, there is so much backpack in there and things like that I want. Then the CMD Bell sitting in the DAC before RMA said, sir, they are showing the numbers okay, but the numbers whatever it is another 1.5 years will be over and what do I do? You give me a continued orders. After that also there is a order book available for me. Within about 4 months, this same 60 missiles per month, I am making 120 missiles a month. That is what very strongly the CMD BDL said that day. So how do we make that? So these are all actually strategies and policies and mechanisms which we need to bring in to see that there is a continued process for the industry and he is able to do it, is sort of a thing, which whether it is the country or the country is able to, how the manufacturing or anything industry comes forward. The moment orders are there, always industry will be ready to come out with modern technologies, modern mechanisms and processings and all that. So for that, this country alone may not be able to supply or give the orders for continued for 5 years, 10 years or hundreds of numbers, thousands of numbers and all. So what happens is the export is the solution. If the export is the solution, how do we? As I said, one is technology, second thing is the marketing support what the country needs to provide. The country needs to provide the marketing support. It's not that each individual industry who is having a small subsystem, he can go around the globe and try to give it. So that mechanism we need to create again. So that is what I am saying. So these are all policies, strategies, mechanisms which need to be created in the country to see that the industry flourishes, the R&D flourishes and technologies, mechanisms come, innovations come is one thing. Today how innovations have come in this country, how so many startups have come. There are so many mechanisms which have come here to encourage them. Every education institution, every state government has an incubation center which is supplying like T-Hub what you have here. Every academic institute, you go to any IIT, you have that park, research park, something, industry park, industry this, that, so many things are there. There are so many mechanisms, every department like IDEX, TDF, telecommunications, so many things are coming which are supporting them. So the moment you do the support, so many things will come up and people feel that is encouraging and I have a mechanism, I have the process, I have the support, all that comes and people will take it up and go ahead. So look at those processes and mechanisms, what needs to be created in the country so that the country, the ecosystem in the country will catch up and take it forward in these technologies, whether additive manufacturing or defense manufacturing capability. This is what I feel. Thank you very much. My best wishes to you. Thank you.
Thank you very much, sir, for an eloquent and thought-provoking address, as always. We would now like to express our appreciation to the dignitaries who have taken time out of their hectic schedules and graced this occasion. I request Professor Indranil Manna, President INA, to present the mementos. First and foremost, to the chairman of the session, Dr. G. Satish Reddy. To Sri G.S. Srinivasmurthy, the co-chair of the session. To the coordinators of the two technical sessions, Dr. G. Madhusudan Reddy, and to Sri Jitendra J. Jadhav. Thank you. Silent gratitude isn't much use to anyone, so let us vocalize our gratitude to all those who have toiled day and night to ensure the stellar success of this event. I now request Lieutenant Colonel Shobhit Rai, Officiating Executive Director, INA, to deliver the vote of thanks.
So, ladies and gentlemen, esteemed dignitaries on the dais and off the dais, on behalf of Indian National Academy of Engineering, it is my proud privilege to propose a vote of thanks for this remarkable event. You would have noticed a number of thank yous have already been delivered, but that doesn't make my task any easier. It is my profound duty to honor and thank each and everyone who has been at the cutting edge of this event in helping us execute this marvelous conclave. First of all, we extend our deepest thanks to Dr. Samir Vikami, Secretary DRDL and Chairman DRDO, for his invaluable support and partnership of DRDO with INAE, which played a pivotal role in the successful conduct of the event. I am delighted to express our heartfelt gratitude to Dr. Satish Reddy for chairing the valedictory session and delivering an inspiring address that captured the essence of the discussions and in general the problems associated with this complicated field of engineering. He outlined a path forwarding, aligning and objectives of the Engineers Conclave. Dr. Reddy, of course, has stolen the thunder. He discussed the event of 2013, which I was to say. Thank you, sir, for that start. Special thanks to Shri G.A. Srinivasamurthy, Distinguished Scientist and Director, DRDL, for graciously making this beautiful campus and venue available, ensuring the seamless conduct of the conclave. Similar thanks to Shri U. Rajababu, PG, MSS. We also extend sincere appreciation of Dr. Jayatith R. Joshi, Program Director, DRDL, Hyderabad, and the convener of Engineers Conclave 2024, and his dedicated team of scientists and staff. Their tireless efforts and invaluable time ensured that all technical and administrative arrangements were executed with highest level of efficiency and commitment. A heartfelt thank you to respective coordinators, Dr. G. Madhusudan Reddy, Chairman of INAE Hyderabad Chapter, and Shri Jitendra J. Jadhav, Director General, ADA, Bengaluru, for emphasizing the critical issues discussed and driving the actionable recommendations to inform the policy formulation and advance the relevant sectors. We are immensely grateful to the esteemed former presidents of INAE, yesterday Dr. Anil Kapotkar, and for both the days, Dr. P.S. Goyal, Dr. B.N. Suresh, and Dr. Sanat Mishra. Their presence, wisdom and guidance significantly contributed to the success of this conclave and many more before this. A sincere thank you to all the sponsors who generously contributed to this nation building initiative, in particular DRDO, our principal sponsor, gold sponsors Brahmos and HAL, silver sponsors Midhani, BDL, BEL and BEML, bronze sponsors ECIL, Messrs. L&T, Messrs. Godrej, ACE Designers, with Objectify as another valued sponsor. We are deeply thankful to the plenary speakers, session chairs, panelists and keynote speakers for their thoughtful and dedicated efforts ensuring the success of this conclave. Special appreciation to our leadership, particularly Professor Manna, President INAE, Shri J.D. Patil and Professor Chakravarti, our esteemed fellows of Hyderabad chapter, including Dr. Dasrat Ram and others' guidance and contributions during the preliminary planning of the meetings, which were instrumental in steering this event to the success. We also express our gratitude to the esteemed fellows, dignitaries, partners from industry, academia and scientists, whose participation was key to make this event a resounding success and fulfilling its objectives. My humble thanks to organizers, members of various subcommittees at DRDL, their teams of scientists and staff who shifted from their primary roles to ensure the precise execution of this grand event. A special thanks to Ms. Madhavi, whom we would pester incessantly anytime. A note of appreciation to our MCs, Dr. Sandhya Nayak, Dr. Gopi Krishna, as well as talented Ms. Guru Priya and Ms. Bhavna Shri, for offering us the beautiful experience of witnessing the graceful Kuchipudi dance performance yesterday evening. My sincere thank you to dedicated team of INAE, led by Colonel Atul Sharma, our Principal's Project Officer, Ms. Pratigya Laur at INAE, for meticulous planning and ensuring smooth conduct of this operations of this complete event. I now invite Dr. Jayatith Joshi on the dais, please. Joshi sir, I request for a small memento as a token of our appreciation for all the efforts. the tradition of organizing the INE Engineers Conclave will undoubtedly continue thanks to the active support of fellowship and the broader engineering community. As we have witnessed over the past 2 days, our gratitude goes out to all who have contributed to the success of this event. Jai Hind, and now I hand you over to our MC.
Thank you, sir. The American writer Stuart Brent has said, "Once a new technology rolls over you, if you are not part of the steamroller, you are part of the road." This two-day Engineers Conclave 2024 has certainly helped keep us abreast of the latest research and work being done in the fields of additive manufacturing and defense manufacturing technologies. As they say, knowledge is like money. To be of value, it must circulate. And in circulating, it can increase in quantity and hopefully in value. Let us continue to keep learning, keep growing, and keep circulating the knowledge through platforms such as this, and in doing so, help our nation achieve greater heights of glory. With this, we have come to the end of the Engineers Conclave 2024. Thank you and have a good day.